Good afternoon. In this demonstration, I'm going to show some of the features of the Qckvu3 viewer so you can see that it's a useful tool for examining your data prior to running the conversion. I've loaded the ODB++ file that we created using sfgen, and now if I want to zoom in, I have several options. I can just drag my cursor and you can see it refreshes very quickly. If I want to pan, I just hold the middle button down and then I just drag it to where I want it to go. If I want to zoom in and zoom out, I can just roll the middle button one way to go out and the other direction to go in. So you can see that all of the manipulation is very fast. If you need to go to the other side of the drawing, you zoom out, pan over, and then roll in. If you want to measure, say, the width of this trace here, you go to the measure tool and then you can click on a vertex. Now notice that it snaps to the vertex. Remember, we're in GDSII, so everything is boundaries, and now it snaps to the other vertex, and here it reports that the finger is 700 microns wide. So there's a nice measurement tool. However, you cannot easily snap to things like this because while in ODB this might have been a flash, by the time it comes to GDSII, it's just part of a boundary that's been merged. So this was originally a flash, a trace, and a flash, and now you can see that it's just one clean boundary. So you cannot easily find these centers, although we have another functional tool that allows you to find centers of circles and squares, which is good for finding the coordinates of alignment marks. If for some reason you wanted to send somebody a picture of what you're seeing, you can always go to File and click Export Image, and then save it as a GIF, a BIMP, or a TIFF, and you can control the scale and the file name. Very often, it's necessary to find the coordinates of several tooling holes in the CAD layout and compare them to the coordinates that you can measure on the substrate. This allows you to correct for any stretching or distortion of the substrate. And we've built a plugin for Qckvu that does this for you. Now the problem you're normally faced with is that these circles are not flashes, but they're boundaries, so they actually have no center. So the correction viewer has a centroid finding algorithm that allows you to click inside the figure and to find the center point. So to do that, just click on Pick Point and then click somewhere near the center, and you see it computed the center, snapped to it, and provides the coordinates here, and you can just update the point. Now we can move out to another point. Let's say we come over to this one and zoom in, and then we click Pick Point again, and again we find the center, update that point, zoom out a third time and move down to the bottom of the board, and then zoom in and select Pick Point, and it grabbed it, and we'll update that, and then finally the last time we'll move out to this side of the board and zoom in. And finally, the last point, we'll update that. And now we can add this to the list. And we have this in a list. We don't care about these other parameters. They're a delta for correction purposes. And then we could save this to a disk file or copy and paste it and do whatever we need with those coordinates.